Alright, let's do an example, another example, and this one is going to be a quadratic. So we got some stuff going on here. So quadratic, the other two examples I just did were linear. And we're going to do this quadratic with a square root technique. Alright, so with a non-trig equation, that might look something like this. 2x squared equals 9. Okay. So you needed to solve for this, and you first would divide both sides by 2, and then you get x squared is 9 over 2. And then to solve, you would take the square root of both sides. So then you end up with x is plus or minus, and this is the square root of 9 over the square root of 2, which turns out to be plus or minus 3 over the square root of 2. I'm not going to rationalize it. I'm just trying to demonstrate the square root technique. Alright, so we're going to do the same thing with a trig function. So this one is going to be 2 sine x squared equals 1. So here's my quadratic because I got a squared, and we're going to use the square root technique. So step 1, we're going to divide both sides by 2. So now I have sine x squared is 1/2. And now you're going to square root both sides. So you end up with sine x is plus or minus the square root of 1/2. Alright, so the square root of 1/2, let's do that work over to the side so you can see what that looks like. Square root plus or minus. Okay, so we get the square root of 1 over the square root of 2, which is 1 over the square root of 2. And when you rationalize that, you end up with 2, square root of 2 over 2, and that looks very familiar to you. Now, look here how we got the plus or minus. Okay, so we get sine x is plus or minus square root of 2 over 2. So draw your circle, and then you say to yourself, where is the square root of, where is the sine, the square root of 2 over 2? And let's see, I didn't state what this one was, degree or radians. Let's do this one in, radians also. There we go. Alright, so everywhere that we have your pi over 4, and your 3 pi over 4, and your 5 pi over 4, and your 7 pi over 4. In some of these places the sign is positive, and some of these places it's negative. So I could turn that into an inverse equation. So x equals inverse sine of plus or minus square root of 2 over 2. And so then x equals all 4 of those locations where the sign is either plus square root of 2 over 2 or minus square root of 2 over 2. So we're just going to list them. 5 and 7. Okay. So we have 4 solutions here. You already knew you were going to get double solutions, so to speak, because it's a quadratic. But generally, and I say generally, these trig equations have double solutions because there's always 2 places where, in this case it's the sign, where a positive sign occurs or the negative occurs. So that's what gives us our 4 solutions here.